Hello everyone, and welcome back to a new lesson about IB Math. In today's lesson we will be studying homogeneous differential equations, which is a topic in the IB Math AA high level. Now you remember on our channel we did differential equations that can be done by integrating factor or separation of variables or even Euler method. This is the last type of differential equations. First, we'll understand what we mean by this, and after that, we'll explain the steps on how to do it correctly and get the answer confidently. First, what are homogeneous differential equations? Here, as you see, we have a differential equation. If you check that, the power on this term is 2, and on this term also 2, and here we have 2. Even here, the power on x and y, since you don't have a power on x, it will be 1, and on y we have 1. If you combine the powers for this single term, it will be 2. So all of the terms have the same power, 2, 2, 2, 2, which confirms that it's homogeneous, so that all of the terms have the same power. It doesn't have to be 2, it could be 1 or 3 or even 2. So that's why it's homogeneous, and it will be done in this way. To solve them, you will always substitute y equals v multiplied by x. V is not a constant number, so be careful about that. V is a function of x. Like later we'll discover that v will be sine x or x squared or whatever when we solve. So v multiplied by x. If this is y, which is equal to v multiplied by x, you can apply the product rule in differentiation that you learned previously before differential equations to get the derivative of y. Let's check together. If y is equal to v multiplied by x, keep in mind that v is a function of x, so to differentiate these we have to apply the product rule. So now we'll say dy over dx equals, you remember the product rule, it says keep the first one v as it is, but differentiate only the second one x, so differentiate x, which will be 1, plus, now the opposite, you will keep the second one now x as it is, but differentiate the first one v. What's the derivative of v? It's not 1. Like when we differentiate x, it will be 1. V is a function of x that we don't know generally till the end of the solution. So that's why the derivative of v will be simply dv over dx. Here you can ignore the 1. So it's just v plus this, which is this as we wrote here. So now, after that, we will replace y and this dy over dx in this equation. After that, we will simplify till we reach a separable differential equation in x and v only, no y at all. Then we'll integrate both sides as we learned before, and then we'll substitute v back. We'll see now step by step. So here, we will replace dy over dx by what we said here, v plus this. And also we will not keep the y. We will remove this y and put instead v multiplied by x here and here as well. So now here you will see in the first step I replaced dy over dx by all of this as we got here. So x squared times dy over dx, which is this. Instead of y squared here, I replaced the y by vx and x times y, so this is also here vx, which is instead of y. Now as you notice, after that we don't have any y or dy left. Now we will expand and simplify. So here, as you see, when you expand here, x squared multiplied by v, you will have x squared times v, x squared multiplied by x times dv over dx. Here, if you multiply this by this, you'll get x cubed. So here, as you see, we have x cubed times this. Here, you can distribute the power of 2 on v and on x, as you see. Here x times x will be x squared, and here we have plus x squared. Notice that we can cancel here x squared v and x squared v. So the resulting equation now after cancellation will be, here as you notice we have the same equation but after we cancel these terms. So now you can also here still after simplification we can here for both sides divide by x squared. So if you divide both sides by x squared, you will get x cubed. When divided by x squared, you will get only x. Here x squared will be gone because we divided by x squared, we have only v squared, and here x squared divided by x squared, 1. Next now, after we reach this, notice that it's a very simple equation where we need to separate the variables and then integrate. We studied before how to separate the variables easily here. Here, to separate, we will move all the x's to the right and all of the v's to the left. So x and dx will move here, but they will be flipped upside down. And also, we will divide by v squared plus 1 to move it down next to dv. So here, we will get this. After I divided by v squared plus 1, I got this 1 over v squared plus 1 times dv, and the x over dx moved to the right and then flipped. But keep in mind that when you write dx over x, it's the same as 1 over x times dx. That's why I wrote it like this, easier. Next now, here, since we reached this step and we separated the variables, we'll integrate both sides. So if you integrate here and here, what will we get now? You know from the formula booklet that the integral of 1 over v squared plus 1 will be arctangent v. And the integral of 1 over x is ln x, the natural logarithm of x. So here, as you see, we have arctangent v, and when we integrate 1 over x, we'll have this plus c. But at the end, we need v now, not arctangent v. So, to eliminate arctangent v, we will take tangent of both sides. Or we will say, to take v outside here, to extract v, it will be tangent of the right side, ln x plus c, as you see. This is v. But when solving differential equations at the end, we need y, not v. And as you see, y is v multiplied by x. All of this journey here is to find v. Since we found v here, then the final answer will be y equals v multiplied by x, which will be v, which is this, v multiplied by x. I will write x first and then v, which is tangent ln x plus c. So this is the general solution to this differential equation here. I hope that you have found this video helpful. Please hit the like button and consider subscribing. Thank you for watching.